Hello students, once again welcome back to Misostudy video classes, and I hope you are enjoying the topics that we have completed till now in this particular chapter, that is electromagnetic induction, very important chapter. So, in that particular chapter there is one very important device description, and after getting the understanding of this device, that is AC generator, you may start your own power company, fine. So, you can produce your own power, you can start selling that power, so there is no need of studies after class 12th. So, just try to focus for this particular chapter, learn all these concepts, those are discussed in this entire chapter. And electromagnetic induction is really very interesting and important chapter, not only for your board exams but also for your competitive exams, and repeatedly I am repeating these sentences. So, it means there is some weightage for that. Now, I am coming on to the AC generator. So, first few points I would like to mention, I will tell them also, fine, but just one by one I will write, then I will explain. So, what exactly this generator is? First point I would like to mention about it: a device that can convert mechanical energy as or in grammatically what is correct, you can adopt it. A device that can convert mechanical energy as or in electrical energy. Fine. So, this is one point. I will give some examples of this, do not worry on that part. I think in the meantime, I should also mention one more important aspect, then I should start elaborating, because both these points I hope I can show you together. So, next point I would like to mention, this device works on the principle of electromagnetic induction. Now, let us start talking something important about these two aspects. One is, this AC generator is an setup, it is a device, it is a machine that converts mechanical energy into electrical energy. If I am saying it converts chemical energy into electrical energy, then will you accept this? Okay. Let us talk about generators, forget about this. In generator you are using petrol or diesel, fine. So, by means of burning of this fuel, that is a chemical process, adding of air, then combustion, then you can say this Carnot cycle, fine, then the piston works. So, their first chemical energy gets converted into mechanical, then mechanical energy ultimately responsible for this flux change. So, then it is finally electrical energy. Ultimately, this device is responsible for converting one form of energy, it may be chemical, it may be mechanical, into electrical. In general, what is happening? In general, you have powerhouses, fine, and in India they are like you can say hydropower plants, then thermal power plants. In hydropower plants, you have constructed big dams, say for example Tehri Dam, Bhakra Nangal Dam, and so on, Sardar Sarovar Dam, like this. So, water is accumulated in a big huge reservoir, miles of area inside that, and then this water is allowed to fall on the blades of the turbine machine. So, that turbine machine rotates, accordingly I will show you with the help of a diagram. The coil associated with those blades also rotates between the poles of two big magnets, flux change and then induced EMF or induced voltage generated. In thermal power plants we use normally coal, fine. So, coal is used to vaporize the water and then the water vapor that passes to the turbine blades. It is similar to the steam engine principle, and then go back to more advanced forms of like nuclear power plants. In nuclear power plants the heat energy is used, they are also basically thermal power plants, nuclear. Why? Because nuclear fission provides you enormous amount of heat energy. This heat energy by means of heavy water D2O circulated and then hot water also used over there to convert it into vapor, and that vapor runs the your blades of the turbine. So, ultimately one form of energy converted into another, but final outcome is electrical energy. So, this device definitely works on the principle of electromagnetic induction. It means what? It means it means flux change, that is phi b is associated, fine. Flux change phi b is associated. So, it is like that phi 2 minus phi 1, so that is delta phi, and because of this phi this change of flux, you can say that this induced EMF, which you know is given by minus d phi b by dt. Accordingly, this induced electromotive force or voltage is generated, and then current, and then it provided to the industries, schools, houses, and like that, fine. So, this AC generator is basically, this is the idea of this AC generator. Now comes a point in the mind, what are the essential components of a AC generator, fine. So, what I will do, I want to erase all these points because I want to create a big diagram over here, and that too I want to create it over here so that I can retain this diagram for long time. And these 3 points, let me summarize quickly. This is a device. Whenever you have to write an answer, you should write in this format, fine. So, what you should say? Device convert mechanical electrical. These 4 underlined points or words you should remember. So, by that you can expand your answer. So, what I will do? I will erase out all these aspects, fine. Those are basic you can say introduction parts, and then I will create a big beautiful diagram, colorful diagram, and in that particular diagram one by one I will elaborate all these things, fine. The basic point which I just removed, I hope you can retain them as they are really very fundamental in nature, fine. So, first is the diagram, that is important. So, let me allow to create this diagram. This is one pole of a magnet. Say for example, like this. This is, say for example, north pole. Then let us say over here it is, basically they are curved, and I should draw them like that, but for the understanding you can say it is really not a problem. So, you can understand it, fine. So, this is let us say south pole. So, now you can say two poles of a big magnet, and in between this there is a rectangular shaped coil. The coil shape may be of any type, no problem, fine. Then actually at this point there are various other components associated. I will try my best to show those components with as much accuracy and clarity as I can produce. Okay. So, this is coil, north and south pole, then there are various components present over here, fine. Now, what exactly is taking place? Imagine the situation. I hope now this idea is very much clear in your mind. By any means, like by falling of water over here, fine, on that blades associated, or you can say by means of vapor. Actually, you are supposed to rotate the coil in this fashion, anyhow. So, ultimately let us say the coil is rotating in this manner, fine. If I am taking from the front view, then it is in clockwise fashion. So, ultimately flux is changing phi b, because phi b is equal to B A cos of theta. Now, B is not changing, area is not changing, but theta is changing. So, if flux is changing, it means induced EMF minus d phi b by dt will also change. So, because of the change in theta, this quantity, fine, flux is changing. So, induced EMF will be produced. Here B is not changing, area is not changing. So, this is your, you can say, schematic diagram, fine. So, first simple point I can write down: due to change in angle theta, phi b flux is changing, fine. This is first point. Now, there are certain important components and those names of the components are really important, and if this question is asked in your board exams, you should, if you are unable to write down so many things about these components, then at least try to remember the name of these components, fine. So, that is why I am mentioning these names over here for your understanding. So, principle I mentioned, device details I provided, the diagram, simple diagram is in front of you. If in your examination you have to write down, just use 2-3 colors pencils and create this beautiful diagram, fine. This schematic diagram is enough. So, construction. Now, be careful for this, you can construct your own powerhouse. Number 1, important segments of AC generator, fine. So, first one is number 1, armature, fine, that is utmost important. If you are unable to recall this name, just for your understanding, it is not advisable to mention over here, you simply say coil in bracket red color. This is for your recalling. So, armature is one first component of this device. Now, what do you mean by armature? Armature is, just take a look of this coil, colorful coil. So, that is why I mention armature. It is arrangements of wire turnings. I think better word is windings. Wire windings, fine, and it is arrangements of wire windings in various shape. Okay. So, that is true about armature, and if you are unable to recall, you can simply mention coil. So, if the diagram is big one, you can mention the name of armature over in the diagram also. Then number 2, it comes FIELD, field magnets. So, what you should write down in this line in field magnets? There are two big magnets, I mean two poles of a big magnet, and the armature or coil is arranged in between them in such a position that it can rotate, fine. So, this is something that you can write down about field magnets, and also you can say in the diagram as for example, there is a magnet with the north and south pole, fine. Then third point comes at slip rings. Now, what are slip rings? Actually, I tried to create this slip ring using this blue color chalk, this one. Actually, slip ring is, suppose at any point of time I want that this chalk holder should rotate like this. So, I will have to definitely a type of ring or something arrangement in which I can put it and it can rotate, fine, something like that. So, this is the arrangement slip rings, so that it can easily rotate, because if there is any friction, then it will create losses of energy, fine, heat generation, so that will create a problem. So, slip rings is something which is used, which help out to rotate this armature easily, fine. So, third aspect is slip ring. Then fourth one is brushes. Now, does change in magnetic flux induces electromotive force or current? So, it is a confusion in the mind that flux change, that is phi b, is giving me basically EMF or current. So, simple, till now we learned that induced EMF is equal to minus d phi b by dt, fine. So, from here this induced EMF is coming first into picture, then induced current is I induced, sorry, that is this I induced is like I induced is equal to this upon load resistance or resistance. So, the answer should be flux phi, this induced EMF will come after the changes in magnetic flux will take place. Current is not the first thing that will come into the situation. Okay. So, here now it is going to be question number 1, and in 1 mark as usual I am telling you, you just have to mention some basic points. So, here with the help of this small remote, I am changing the question and it is your second question. If a wire is kept in east-west direction is dropped freely, what will happen? Now, actually they want to know a very simple and fundamental aspect, whether you have the idea of two components of Earth's magnetic field or not. Fine. So, you know Earth's, there are two components of the Earth's magnetic field. One is BH, horizontal component, fine, that is like in this direction horizontally, and another is VB, that is vertical component. So, the direction of vertical component is like this, fine. Now, when the wire will start falling in east-west direction, so their question is what will happen? So, the answer should be at the ends of the wire an induced EMF will appear or potential difference will develop, fine. Why the potential difference will develop? Because, not because of VB, but because of BH, because the wire, fine, when it will fall, so it will cut these lines, horizontal lines. Because of this reason, there will be a potential difference at the two ends of wire, let us say wire end A, wire end B, fine. So, what your answer should be? Your answer should be when this wire will start falling freely, because it will cut the BH, that is horizontal component of Earth's magnetic field. So, it will induced EMF will come into picture, fine. Now, it comes question number 3, and in question number 3 you know 2 marks, fine, not only 3 but question number 4 also. So, these two equations are for 2 marks each. So, show that rate of change of magnetic flux has the same units as induced EMF. Actually, when I was explaining various theoretical topics of this chapter, at that point of time, even I emphasized a lot that you should know the dimensional formula of L, self inductance, M, mutual inductance, induced EMF, voltage, potential, I mean all these type of quantities, dimensional formula you should know. So, here show that rate of change of magnetic flux, rate of change of magnetic flux has the same units as induced EMF. So, do not you think both are correlated? Basically, we are saying left hand and right hand part. Actually, EMF is phi B by dt. Now, you have to show, fine. So, you need you cannot say okay because they are correlated, so dimensional formula is going to be equal because left hand right hand parts are equal or something like that. Logical approach is you show it. For 1 mark you show it this, and for 1 mark you showed like this. So, from here let us start from this box. If I will start from this box, then I can write it down as B A upon T, because cos theta no dimensional formula. And about induced EMF is nothing but similar to V. So, the dimensional formula of potential is going to be equal to the dimensional formula of this quantity and the dimensional formula of this. So, both sides you can say now they are simple, equal to each other. Let us say you do not have time, just for the sake of simplicity I am telling you, then simply you can say in physics two quantities proven to be correct, they can be equal to each other only if dimensionally they are same. Left hand side dimensional formula is equal to right hand side dimensional formula, but that will be like somehow you are forcing your answer. So, better to show like this because it is mentioned show, fine. So, it was question number 3 and it was for 2 marks. So, I hope getting these 2 marks is not a difficult part, fine. 1 mark you can show this induced EMF, and for next 1 marks you can show this second part, that is d phi by dt. Then comes question number 4. It is a type of numerical, and whenever you are getting any numerical, then you should try to pick that numerical if the choice is there. Reason is simple. Numericals are in general easy, and if you solve them correctly without any units error, without any calculation error, then possibility is for scoring full marks. Fine. In theoretical answer, if it may be possible like that you are writing and then you are missing 1 or 2 points, so maybe half or 1 marks may be deducted. Okay. So this is the situation, but if you are 100% sure that you can solve this numerical, only then pick that numerical. Otherwise, better is to at least attain few marks rather than losing full marks. Fine. So a circular brass loop of radius A and resistance R is placed with its plane perpendicular to a magnetic field. Fine. Let me allow to draw the diagram. Actually, this is a circular brass loop. Fine. And it is placed, its radius is, I think I should draw it more clearly. First read the second line also. The magnetic field is given by like this. So you can say magnetic field is changing with respect to angle, time. Fine. Now let us draw the diagram. So just take a look. This is a circular brass loop and radius is A and resistance is R. It is like that. I am observing it from the top. Fine. Okay. Now magnetic field is perpendicular. So as it is not mentioned plane perpendicular to a magnetic field, so it is your liberty. Either you can put the magnetic field like this or like this. So let us say magnetic field is like this. Fine. As it is not given, so this is perpendicular, not a problem. Fine. Because area is not changing, because theta is not changing, but magnetic field itself varying, itself changing. So flux change will take place and then induced current. Now first you have to calculate the induced EMF due to flux change. Then I will calculate the current as using the formula I induced is equal to by R. Fine. So our first target is to calculate induced EMF. Fine. So from here I can write it down as this relation I is equal to this much R is equal to d phi B by dt upon R. No problem, simple relation. Now consider this magnetic field. Actually simple trick is used over here, very simple trick, that is d phi B by dt is equal to d by dt and then this BA, A is pi A square, that is not a problem. You should put it outside rather. Fine. So yes, you should put it outside of it. So it is going to be like this, pi A square d by dt of B naught sine omega t. Fine. Simply differentiate it, you will get this I finally is equal to minus A omega B naught cos omega t upon R. I used pi A square, you can also, fine, no problem. So for 2 marks this question is very simple question. Okay.